V.Nivaethithaa and my registration number is 21BCE1891. And I'm here to explain on the topic applications of context-free grammar in speech recognition. Let's go to the introduction to speech recognition. Speech recognition, also known as automatic speech recognition, is a computer speech recognition or speech to text. It can process human speech into a written format. It's commonly consumed for voice. Speech recognition focuses on translating speech from a verbal format to a text one, whereas voice recognition seeks to identify an individual user's voice. Automatic speech recognition with NLP is a topic trending to various kinds of research and innovations. Many types of models and methods are available using existing technologies to recognize speech. Siri, Alexa, and Google Assistant demonstrate what ASR and NLP have achieved thus far. Natural language processing helps computers learn, understand, and produce content in human or natural language. Text or character recognition and speech or voice recognition are capable of inputting the information in the system, and NLP helps these applications make sense of this information. NLP-based systems are especially effective for augmenting both human-human communication like language translation and human-machine communication like virtual assistants. Now let's head on to what is grammar. It is a set of rules which checks whether a string belongs to a particular language or not. A program consists of various strings of characters, but every string is not a proper or meaningful string. So to identify valid strings in a language, some rules should be specified to check whether the string is valid or not. These rules are nothing but make grammar. Example, in English language, grammar checks whether the string of characters is acceptable or not. That is, checks whether nouns, verbs, adverbs, etc. are in the proper sequence. Example, a string is inputted, it checks the grammar, and the output is whether that grammar is acceptable or not. Next is introduction to context-free grammar. Context-free grammars can generate context-free languages. They do this by taking a set of variables which are defined recursively in terms of one another by a set of production rules. Context-free grammars are named as such because any of the production rules in the grammar can be applied regardless of context. It does not depend on any other symbols that may or may not be around a given symbol, that is, having a rule applied to it. A context-free grammar is a form of grammar which is used to generate all the possible patterns of strings in a given formal language. Context-free grammars are studied in fields of theoretical computer science, compiler design, and linguistics. CFGs are used to describe programming languages, and parser programs in compilers can be generated automatically from context-free grammars. Next, let's on to past structure rules and tree diagrams. It has subject, noun phrase, verb phrase, prepositional phrase, and adverb phrase. Let's see the examples of it. First example is the boy. The boy is a noun phrase. It is split into determinant and noun. Here the is determinant, boy is noun. Next is the boy in the yard. The whole sentence is a noun phrase. It is split into determinant, noun, and prepositional phrase. The here is determinant, boy is noun. In here is preposition. Again, prepositional phrase is divided into preposition and noun phrase. And it is again noun phrase is divided into determinant and noun. The here is determinant and yard here is noun. Next, let on to the more examples. First, took the money. The whole sentence is a verb phrase. The took is the verb here and noun phrase is divided into determinant and noun. The here is determinant, money here is noun. Next is took the money from the bank. The whole sentence is a verb phrase. It is split into verb, noun phrase, prepositional phrase. Took here is the verb. The money, the here is determinant, money here is noun. Prepositional phrase is divided into preposition, noun phrase, and noun phrase is again divided into determinant and noun. From this preposition, the is determinant, bank is noun. The old tree swayed in the wind. The whole sentence is a subject. It is divided into noun phrase and verb phrase. Noun phrase is divided into determinant, adjective, and noun. Verb phrase is divided into verb, prepositional phrase. Again, prepositional phrase is divided into preposition and noun phrase. And noun phrase is divided into determinant and noun. The here is determinant, old is adjective, tree is noun. Swayed here is verb, in is preposition, the here is determinant, wind is noun here. Now let's head on to the parser. First is top-down parser. When the parser starts constructing the parse tree from the start symbol and then tries to transform the start symbol to the input, it is called top-down parsing. Recursive descent parsing. It is a common form of top-down parsing. It is called recursive as it uses recursive procedures to process the input. Recursive descent parsing suffers from backtracking. Backtracking. It means if one derivation of a production fails, the syntax analyzer restarts the process using different rules of same production. This technique may process the input string more than once to determine the right production. The features of top-down parser are: it builds from the root yes node to the leaves. It is expectation based. Now let's head down to the common search strategies of top-down parser. First is top-down, left to right backtracking. Next is first rule with LHS is equal to yes. Next is expand all constituents in these trees or roles. Then continue until leaves or POS. Backtrack when candidate POS does not match input string. Next is bottom-up parser. Bottom-up parsing is more general than top-down parsing. It is efficient and it builds on ideas in top-down parsing. It is preferred method in practice. It is also called as LR parsing. L here means the tokens are read left to right. R means that it constructs a rightmost derivation. Next is shift reduce parsing. Shift reduce parsing uses two unique steps for bottom-up parsing. These steps are known as shift step and reduce step. First, let's learn about shift step. The shift step refers to the advancement of the input pointer to the next input symbol, which is called the shifted symbol. This symbol is pushed onto the stack. The shifted symbol is treated as a single node of the parse tree. Reduce step. When the parser finds a complete grammar rule RHS and replaces it to LHS, it is known as reduce step. This occurs when the top of the stack contains a handle. To reduce, a pop function is performed on the stack, which pops off the handle and replaces it with LHS non-terminal symbol. Next is LR parser. The LR parser is a non-recursive shift-reduce bottom-up parser. It uses a wide class of context-free grammar, which makes it the most efficient syntax analysis technique. LR parsers are also known as LRK parsers, where L stands for left to right scanning of the input string, R stands for the construction of rightmost derivation in reverse, and K denotes the number of look-ahead symbols to make decisions. Now let's add on to the rules for LR parser. First rule is that the first item from the given grammar rules adds itself as the first closed set. If an object is present in the closure of the form A, alpha, beta, gamma, where the next symbol of the symbol is non-terminal, add the symbol's production rules where the dot precedes the first item. Repeat steps B and C for new items added under B. Next is uses of context-free language. In speech recognition systems, a computer system attempts to identify a sequence of words from a speech signal. One way to improve the accuracy of the recognition is to limit the recognition to a set of selected phrases. This is typically done by limiting valid recognition hypothesis to phrases that are found in a context-free grammar. The grammars are used by speech recognizers and the other grammar processors so that developers can specify the words and patterns of words to be listened for by a speech recognizer. The syntax of the grammar format is presented in two forms: an augmented BNF, ABNF form and an XML form. The specification ensures that the two representations are semantically mappable to allow automatic transformations between the two forms. Next, augmented BF syntax ABNF. Let's learn about it. This is a plain text non-XML representation which is similar to traditional BNF grammar and to many existing BNF-like representations commonly used in the field of speech recognition, including the speech grammar format JSGF, from which this specification is derived. Augmented BF should not be confused with extended BF, which is used in DTDs for XML and SGML. Next, let's learn about the XML. This syntax uses XML elements to represent the grammar, constructs and adapts design from the PyBeach grammar, TOC-ML, and a research XML variant of the speech grammar format JSGF. Both the ABNF form and XML form have the expressive power of a context-free grammar. A grammar processor that does not support recursive grammars has the expressive power of a finite state machine or regular expression language. Next, a grammar processes any entity that accepts as include grammars as described or specification. A user agent is a grammar processor that accepts user input and matches that input against a grammar to produce a recognition result that represents the detected input. As the specification title implies, Speech recognizers are an important class of grammar processor. Another class of grammar processor anticipated by the specification is the dual tone multi-frequency (DTF) detector. The type of input accepted by a user agent is determined by the mode or modes of grammars it can process. Example, speech input for voice mode grammars and DTMS input for DTMF mode grammars. A speech recognizer is a user agent with the following inputs and outputs. First input, a grammar or multiple grammars as defined by the specification. These grammars inform the recognizer of the words and patterns of words to listen for. Next is input, an audio stream that may contain speech content that matches the. Next, output, descriptions of results that indicate details about the speech content detected by the speech recognizer. The formats and details of the content of the result are outside the scope of this specification. For informative purposes, most practical recognizers will include at least a transcription of any detected words. Output, error and other performance information may be provided to the host environment. Example, to a voice browser that incorporates a grammar processor. The method of interaction with the host environment is outside the scope of this document. The specification does, however, require that a conformant grammar processor inform the environment of errors in parsing and other processing of grammar documents. So this is about it. Hope you have learned something on this. Thank you.